The next one to look at is integration by parts. Integration by parts stems from this formula. So always remember, this is where integration of by parts stems from. Integration of by parts stems from this. Let's say you're given a function. Let's say you're given y is equal to u times v. Y is equal to u times v. Then you know you could find the derivative of this. You could say that, let's say you're differentiating this with respect to x, then you'd say that in this case dy by dx is equal to, dy by dx is equal to product rule. It's equal to u dv by dx plus v du. So this is just product rule, u dv dx plus v du dx. That's integration. That's how we differentiate using product rule. Now this now, what if we stay so boombox and we want to integrate? So stay so boombox and we integrate both sides. So integrating both sides, what we're going to get is the integral of dy by dx is equal to the integral of u dv dx plus v du dx. So we're integrating all of this. Alright, so let me put this better. Say integrating u dv dx. That's what it's going to give us the integral of dy over dx. Now, when you integrate dy dx, what do you get? You just get back y. When you integrate dy by dx, you just get back y. And so what we're getting is y is equal to the integral of u dv dx plus the integral of v plus the integral of v du dx. That's integration by parts. Now catch the pre now, catch the pre. Now initially we said that y is u times v. So I can replace this y right here with u times v. I'm just gonna write u times v. Now if I were to make u dv dx the subject, the integral of this right here, then what I would get that is that the u integral of u dv dx is going to be equal to, I need to bring the integral of v du dx over to this side. It's equal to uv minus the integral of v du dx. Integral of v du dx. And that would be the integral of u dv dx. Integral of u dv dx. So the integral of u dv dx is the integral of u dv dx is uv minus the integral of v du. So all this is telling us is that anytime we're integrating the product of two functions, we're going to call one of them u and another one of them dv dx, and we're going to use this formula in order to integrate the product of two functions. Right? So this is known as integration by parts. Now in doing integration by parts, there's also what's known as the LIATE rule. LIATE rule is what's going to allow you to identify your u. LIATE. So E stands for exponential functions. So when you say functions like e to the f of x, E stands for exponential functions. T stands for trig. This T stands for trig. All right, so this T stands for trig. This A stands for algebra. So when you see like your 7x squared, your 5x, all of those start of stuff with x, those are algebra. L stand for logarithm. Logarithm meaning when you see your ln x, that's logarithm. And then this stands for inverse trig functions. When you see your tan inverse or your sine inverse, that's your I. All right. And with LIATE rule, it tells us that to choose our U, we start with these functions first. So if I comes before L, A comes before T, T comes before E. All right. So now we're going to use LIATE rule with by-parts to do some questions, and you'll see a clearer picture of what we are talking about. So let's look at by-parts question. So boom shebang. So reach back here, so now. So now it says, show that the integral of cosine inverse 2x is equal to s cos x, x cos inverse 2x minus a half the integral of 1 minus 4x squared. So again, to do this question, what you're going to need to do is write this as the product of two functions. So I'm going to need to write this as the integral of, now this is, I can always break this up as cos inverse of 2x, and anything can be broken up as a function multiplied by 1. So I'm going to write this as cos 2x times 1 dx. Nice. So I wrote it as two functions. I wrote it as a product of two functions. So now what I'm going to do is I'm going to call my u. Then you have to remember LIATE rule. 1 is algebra. Cos inverse is an inverse. And according to LIATE rule, inverse comes before algebra. So LIATE, inverse comes before algebra. Inverse comes before algebra. So inverse comes before algebra. And so this is my u. Cos inverse is my u. This is now cos inverse of 2x. So that's my u. And then remember, it's integral of u dv. And so dv is 1. dv is 1. So now the next thing we need is du. And du is the differential of cos inverse of 2x. To differentiate cos inverse, it's minus the derivative of 2x, which is 2. And that's being divided by the square root of 1 minus 2x all squared. So it's 1 minus 2x all squared, which is 4x squared. That's 1 minus 4x squared. And then v is going to be equal to the integral of 1. When you integrate 1, you just get x. Nice and easy, soft. So now according to LIATE rule, the integral of u dv, the integral of u dv, this is a u, the integral of u dv is equal to uv minus the integral of v du, minus the integral of v du dx. All right, minus the integral of v du. Now again, look at this now. We called our u cos inverse 2x, and it's been multiplied by v. V is x. So what we're getting now is that the integral of cos inverse, the integral of u dv, which is cos inverse times 1, what we're getting is that that is working out to be, let's write it down, the integral of cos inverse, integral of cos inverse of 2x, it's equal to uv, it's equal to uv. I feel like we're not seeing it well, so let's zoom in. It's So we catch it very good. The integral of cos inverse 2x is equal to uv, and going back up, our u was cos inverse 2x and our v is x. So it's going to be x, that's u, and this is v, cos inverse of 2x. So it's x cos inverse 2x minus the integral of v du. So it's minus the integral of v du, v times du. So it's minus the integral of v du, and so what we're integrating is minus 2x over the square root. It's 2x over the square root of 1 minus 4x squared. Now look how easy we're going to ropes up this question now. What I'm going to show you is, look at this. The derivative in the denominator is minus 8x. So I just need to generate a minus 8x in the numerator. To get 8 in the numerator, I just need to multiply by 4 over 4. That's the only way I would generate a 8x. Right? The only way I generate 8x is if I multiply by 4 over 4. Then I bring in this 4. And I bring in this 4 to get my derivative of the denominator is in the numerator. And so now we can use u substitution for that side. So this is going to work out to be equal to x cos inverse of 2x minus, now this is your u and you're calling the numerator your du, so it's 1 over 4 times the integral of 4 times minus 2x is minus 8x. This minus 8x is my du, so it's 1 du being divided by the square root. I'm going to call this part u, being divided by the square root of u. Now 1 over the square root of u is u to the minus half. Now integrating u to the minus half is u to the half. So what I'm going to get is x cosine inverse of 2x minus a quarter. Now again, the integral of u to the minus half is u to the half. So it becomes u to the half over half. But u to the half, this is really u to the half over half. U to the half is the square root of 1 minus 4x squared. It's u to the half. This is 1 minus 4x squared. And this is all being divided by a half. Plus your constant of integration. Now 1 over 4 times 1 divided by 1 over 2. All of this is going to work out to be is just a half. A quarter times 2 is just a half. So all of that part is just going to work out to be minus. It's going to be work out to be minus all of this over 2. The only reason I didn't show the full steps was because of space. So this is what we get as our final answer. And now look at it. Let's check it out. Check it out. There it is. X cos inverse 2x minus a half, 1 minus 4x plus your constant c. And that's integration by parts. We got the answer. So when you get easy question like this, I want you to write soft with a capital T, soft. You want the examiner to hear you pronounce the T soft, soft, extremely soft. All right.